Hi, this is episode 18 of Crondos. I'm your host, Jordan Hudgens. I'm a Ruby dev and the CTO of the DevCamp platform. On Wednesdays, I like to cover a random topic related to development. And today, I'm going to discuss how to study and how to understand complex topics. When I was younger, it took me a while to learn something new, especially a new and challenging subject. But after through about a decade of university and grad school classes, I put together a system that's really worked for me to not only understand and study for a test, but also how to learn on a long-term basis. Most of the things that I study on a regular basis are related to computer science, algorithms, and software engineering research. However, these can be applied to any field of study. While there are near infinite ways to study and learn complex topics, some of them work, some of them don't work so great, I like this approach because it breaks down and takes a divide and conquer strategy for learning anything. It breaks every difficult subject into small, easy to digest components, and then at the end, putting it all together to understand the issue as a whole. So here's my system for how to study. Let's take a case study example, understanding how logarithms work. Logarithms are used throughout the fields of mathematics and computer science. However, unless you use them regularly, it's easy to get a little bit rusty. The first task I'll do is take a piece of paper and write logarithm in the center of it and circle it. Next, I'll go to a comprehensive post on the topic, such as one from Wikipedia. In reading the first sentence, I come across a few terms that are a bit fuzzy: inverse operation and exponentiation. As soon as this happens, I'll stop reading the logarithm article and I go and read those two articles until I feel comfortable with what they represent. After I feel good about these two items, I write them as their own circles that connect to the logarithm circle. I'll also add any examples that'll help me understand what the terms mean if necessary. Next, I'll go to the original logarithm post and keep going through the article, repeating this process until the entire page is filled with a mind map that explains each component that makes up logarithms and how they work together. This may include base cases, such as 64 equaling 2 to the power of 6 is the same as log base 2, 64 equals 6. If this seems like a dead simple approach and a common sense way to study, it is. The easiest way to understand a complex topic isn't to understand as a whole, but to break it down into small, easy to manage chunks and then put it all together. For example, if you're trying to understand a really complex algorithm, it can be a little bit intimidating if you try to do it from scratch. But if you start to break it down into small, easy to manage chunks and you go line by line and see, okay, this line is simply a loop. This line is just manipulating a variable. And you go by each piece, it makes it much easier to understand and comprehend what the entire algorithm is trying to do. A problem is really only hard when you try to look at it as a whole. However, if you break it down into easy to manage pieces, it becomes much more manageable. And that's the same thing for really understanding any kind of complex topic, regardless of your field of study. And the more complex and more advanced you get, you're going to have to break it into a lot of pieces. Obviously, understanding basic addition and subtraction is going to be a lot shorter time to learn than taking, say, the quicksort algorithm or some type of really complex algorithm. That's going to take having to work with much many more smaller pieces. But at the end of the day, it still boils down to something that can be broken into a much easier way of understanding it by compartmentalizing it. I hope you can leverage this mind mapping process to start understanding complex topics, and you can use it the next time you go to study.